Good morning, my name is Michał Strzeszewski and I will be your host for today's presentation. Today I'm going to speak about the two programs, Audytor HL and Audytor SET, because we are speaking about the set of two programs, so the presentation will have two parts, and between the parts I intend to make a small break. Before we start the presentation itself, I would like to show you our website where you can order either Audytor version or branded version of the software. So if you enter our website, suncom.net, you can go to download section, and then first you can enter trial versions. In this section, you can download the free trial version of the programs, and among them Audytor software, so this is our main version. Then you can also enter the sponsored software version, where you can order the sponsored version either of Danfoss or Can brand. All right, so now let's come back to the presentation. We have the details about using the software in our video manuals available on YouTube. So I won't speak about all the possible details how to use the software. I will rather try to explain the main idea today. And I will start with the presentation in PowerPoint, and then I will show you the live program. So in Audytor HL, in English it's called HL, in Polish language OZC, from version 6.0 we have two main methods of work. In both of them we start with the global data. Global data, or sometimes called general data, these are the data about the whole building rather than the specific part of it. Then we enter the building components like walls, roofs, windows, etc. So we can imagine this step like a kind of preparing some bricks, like Lego bricks, that we can use them later on to construct our building. And then we have two options. One a little bit more traditional. We can enter the data about the rooms in the tables. So for each room we create a table. It resembles a little bit manual calculations, though it's automated, so it's faster. But we have also an alternative method. We can create a 3D model of the building. But as you see, we create not only the 3D model, but first of all, we create the flat plan view. Generally, most of the time, we draw on the flat plan view, and the third dimension, in most cases, created automatically by the program. That's simply faster and easier. Only in some cases, like in case of ethics, we use the full 3D editor. Then we start the process that we call import of 3D model. This is the analysis, the automatic analysis. The program analyzes our geometrical model and creates the calculation model. Calculation model, this is simply data for calculations, and we obtain this model in form of the table. As you see, this process creates also the table, pretty similar to that we could have prepared manually. The big difference is that the font is green. The green font means that this was created automatically. But what's very important, we obtain also the visualization. So we also can see and really be sure for what data the calculations will be done. And then we start the calculations, the heat load calculations, and we can obtain and analyze the results. So as you see, we have two methods available. Both of these methods are available, are valid, though I really recommend strongly the second method, the graphical. Why? Because it's got a few advantages. First of all, and I think it's very important, it's much faster. Our tests and also external tests showed that this method is about 3 to 4 times faster. Why drawing is faster than creating tables? Because first of all, as I told you already, we draw mostly on the flat plan view. In 2 dimensions, drawing is pretty fast in comparison with 3D, but the third dimension is created automatically. Secondly, we have a lot of functions that makes our work faster. For example, when we draw first the walls, then the program can create the room zones, the floors in the rooms automatically. The program can, for example, calculate the volume of the room, also in case of complex shapes. So thanks of that, this graphical method, it's much faster than table method. Also, it's much easier to see the mistakes, because in the table, if we forget about a wall, about a window, if the wall is too short, too long, in the table you can't see that fast. You would have to analyze the table in details. In case of visualization, you see immediately if there isn't a wall or the wall is too short or too long. So thanks to graphical method, your results will be much more correct, I believe. And last not least, if we create the geometrical 3D model, this is not only the model for heat load calculations, but also we can apply later on, as we'll speak in the second part of today's presentation, in the second program, in Audytor SET, to design heating, cooling, or water supply systems. So that was explain the general idea, the general two methods. Now I will show you the program. In the meantime, all the time, feel free to ask questions. You can ask questions using the questions panel that you've got in the panel of your program. You can detach it, so you can make this window much bigger, so probably much more handy to write, though probably my colleagues will answer some of your questions in the meantime in the text form. I will be answering the questions during the question sessions later on. But all the time, if your question hasn't been answered, or if you feel that hasn't been answered completely, feel free to contact us. You can write the emails. You can find them on the website. For example, info or sales or marketing, depending on the topic of the questions. If you don't know which to use, I suggest the first one, info@en.suncom.net. General structure of the program you can see if you observe these speed buttons that are under menu. So first we have the global data, and then it's got a few sections, so buildings, so these are the most important information about the projects. As you see, some fields like project name, for example, has got light green background. That means that this is not obligatory. The program doesn't need this information to run the calculations, though in the real design it's better to enter this information because our printouts will be more complete. Then we've got basic data, so a little bit more detailed information, but again about the whole building. Then we've got the stories tab. Here we enter the information about the levels, the heights of elements like walls, and program uses this set of information to create the third dimension. And here we can treat these fields as default data for the whole building. Later on, we can change them if necessary for some stories. For example, basement or attic can have different levels. Then we have the information about the ventilation. And depending on what we choose, in case of natural ventilation, in fact, we don't need additional information. But as you see, the program can model also the situations when we've got much more complex mechanical ventilations. We also enter the information about the thermal bridges. So basically, that's about the construction solutions. For example, for this situation, for the corner, we just can decide whether the isolation is close to the external surface, maybe it's more in the middle, or what we normally avoid, but sometimes we have to, inside. Then radiators, this tab is used only if we would like to run the preliminary radiator selection that we can do already in HL program, though it's recommended to do the precise selection of radiators in SET programs. And at the end, we have some parameters that can influence the way of calculations. Then we have the catalog of materials. The program consists the extensive databases of a lot of materials, but you can add new ones. And then we have the building components. For example, here you can see the structure of external wall. So these are these bricks that we will use later on to construct the building. And then at the end, we have the window that's called rooms. This version, it's a little bit traditional because the program is about 20 years old. I mean, the first version. And in the first version, in this window, you could only enter the list of rooms and nothing else. Now, as you see, it's much, much more. So today, I would rather call it the structure of the building. However, we try to keep these traditional names because we have a lot of users in many countries all over the world. And even though that now our programs are much more advanced than at the beginning, we try to appreciate and respect the skills and knowledge of our users. So we try to introduce new functions, but the amount of new learning from our users should be as low as possible. As you see in some other software, sometimes the functions are the same, but they were just moved, and then you have to look where it is. So therefore, we rather try to keep this traditional names. Therefore, it's called rooms, but in fact, it's the structure of the buildings. This example, as you see, has been prepared using the graphical method. And this graphical model you create in that way that first you create the stories. For example, here you've got the basement. Then you've got two tabs. In the tab basic data, you can see very similar form that you have already seen in the global data. This form, now it's for the basement. So if it's not necessary, we can keep all the data inherited from global data, but if necessary, we can change something. For example, here the ordinate of the story was changed. That's pretty natural because normally all the stories have got individual ordinate, and actually everything is the same as this green font shows, only the level and height of windows is different. So now you can see another convention that the green font can indicate that this value was taken automatically. For example, here using the inheritance principles. And if the font is black, like here, it means that these values were entered here specifically. Then we go to the Plan View tab, and now we can draw the plan view. As I told you, most of the time we try to draw only on the plan view, but still the program creates the third dimension. And then we can see the 3D model of the building. Now this is one story. And we can see the whole building. So it looks like that. This is the third example that is attached to the program. This is a very small building, and I think it's very good as an example, though our software can be used and is used in many countries for really huge buildings. So it's not only for the small buildings, for small buildings as well. Of course, if you intend to design big buildings, it's good to invest in a little bit better equipment, a good computer with a big screen, or possibly 2 screens, and a good graphic accelerator. Though, generally, the hardware requirements are pretty low, so you can design even using the computers that are not so new, and that will still work, maybe not as effectively, but we try to optimize our algorithms in that way to keep the hardware requirements really moderate. This example is very small but pretty interesting, because as you see, you've got different stories on different levels. You've got a basement and then a kind of upstairs and attic, but on the left-hand side, you can see what we can call maybe a ground floor when you've got an entrance and a garage, and how to model that. I think it's a very good example. The easiest way to model this building was to create separate story for each level. So in the structure, you can see the basement, and if I show only one part, maybe let me change the proportions a little bit so you can see better. So as you see, this is the basement, and we have drawn these elements as basement. Then the ground floor, this is this part. Then we've got what we called first floor and loft or attic. So please think about the story as maybe not necessarily exactly the story like the person that lives in this building would think about it, but rather as a kind of possibility of creating the default data, because as you see, each story can have this set of data that can be different, for example, ordinate, and then whatever you draw on this story, first of all, it would receive these levels. You can change it for the specific element, but before doing that, it will obtain this default data. So you have to learn it, but after learning it, you will see that really you can save a lot of time. So generally, the principle of inheritance is that we can create some information as default for the whole building, and then we can modify them if necessary at a lower stages, for example, at the step of the story, or at the end as a kind of exception for the whole, for the specific element. So if you think correctly and decide what's standard at which level, so then you can save a lot of time. All right, so once we created the building, we can see it, and then if I can show you again, then this is this step. So this is the import of 3D model. How to do it? We click this button, import 3D model, The program checks whether there are any big mistakes, but luckily not. So then we start the import, and we obtain the second model, the calculation model. So how to see the calculation model? I have to enter one of the rooms, for example, a boiler. And as you see, I obtain the table with the building components that resembles the manual calculations, and if necessary, I can check or can prove to someone my calculations, but I can see also the visualizations of this room in 3D. And I really recommend that you have a look. You take a second. It won't take you much time in most cases. If you've got the big buildings, maybe you don't have to see it room by room, maybe story by story, but this gives you really the possibility of verifying your data, because now you can be sure for what data the calculations will be done. And if there are any mistakes, you will see it immediately, so you won't spend much time on that. But you can observe one room, one story that in this case the staircase was connected, therefore it goes through a few stories, but it was assigned in the calculation model to the basement, because the staircase was modeled in different rooms. That's a principle, that if you enter the room zone in different parts, but you give the same symbol, the program will sort of glue it together, in quotation marks, at the process of import, and then you see that you can, in this way, model even a little bit complex. So this is our staircase, including with this entrance area. Maybe let's see something else. For example, let's go to the first floor. Now, okay, when I click the floor, I obtain again calculation mode. The geometrical model. So that's the principle. When we select the story, we see the geometrical model. So this is this model that we have created. If we wish to see the calculation models, so we have to choose one of the rooms. For example, I have chosen now the garage, and I can see this garage. I can see that in the context of the building. If I don't want, I can switch it off. So now I have only garage. Or I can see the whole ground floor. Then I can see here I've got a kind of hole, because that was already treated as a staircase and assigned to basement. So maybe now let's choose one of the rooms from the first floor. So now if I selected viewing the whole story, so I can see my first floor, again with lacking the staircase, because staircase is forming the part of the basement. And in the similar way, I can see the attic. So I really recommend to take a few minutes to check, because this is really the place where you can verify whether the model is correct. And it's really important to have correct data to have correct results. So when I obtain the design for some kind of verification, this is what I do. I go through the model, the calculation model, and then immediately I can say whether the model is correct, looks correct or not. But it's really fast and it's really easy to find mistakes in that way. So once we think that the model is correct, so data for calculations are reasonable, so we can start calculations, starting calculations menu or F9, or we can click this icon with calculator. And now, oh, I think it looks that it was blocked, but doesn't matter. And the program also have got a diagnosis. So in fact, first program checks the data, then does the real calculations, and then does the analysis. Okay, let us show the list of diagnosis of the messages. Oh, nothing serious. In fact, it's not connected with the heat load calculations, rather with this preliminary radiator selection, that in some rooms the radiators are a little bit too big because the heat load is pretty low. So the smallest radiators were selected, but still they are too big. As you see, they were marked with the yellow color. Yellow, it means this is kind of warning, but nothing serious. If it's purple or red, that would be more serious. So now, once we have done the calculations, we would like to see the results. So we go to the results menu, and first, like we had global data, we have also global results. So this is the table with the most synthetic information about the whole buildings. And very important is that you can format it, so you can decide which information to show. For example, we have creation time, but imagine that we are doing the design after the deadline and we wouldn't like to show it. So what we do, we right click it, the table, we select the format table command, format table, and then we'll see the structure of this table. This table is not very long, but pretty complex. And sorry, it's in Polish language, we'll have to change it. But here you can believe me that you have the data of creating, and I can switch it off. And as you see, this information of creating disappeared. I can also, maybe even more important, disable the data of calculations. And now you see this row has disappeared. If necessary, we can also export the table to Excel. And in this table, for example, we can find the design heat load of the whole building. In this case, it's 5 kilowatts. Then we can go to some more detailed results. We can have the summary of building components. Is the summary, so you've got only one line, one row for each building component. If you would like to know the details about the calculations of few values, you can choose the next option, building components, and then you see the graphs, the tables that shows the precise calculation. So if there are any doubts and questions, you can check, or you can prove it to someone else. I think it's pretty important that the program tries to document the calculation. So it's not the black box that you put some data and obtain results and you have to believe that it's correct. You've got the documentation. So in case of any doubt, you can go and check, or to show it to somebody else. In the similar way, you can have the set of stories, building zones, group rooms, etc., etc. Let's concentrate maybe on the rooms. Again, we've got the list of rooms. So again, the table, one row for each room, and not all the information is necessary, so we can switch off some of them. And again, we can see the details of calculations. If we choose the rooms, then you would see the tables that resembles the manual calculation. So as you see, room by room, all the information, all the building components. So really it looks like manual calculations, and you've got all the intermediate values. So it's possible to verify the results. And if you have chosen the radiator selection, so you have also this information, but this is only the preliminary, because at this stage we don't have information about the system, so we cannot take into account the isolations of the pipes, the cooling of water in the pipes, and heat gains from the pipes. So it's a kind of approximations, but sometimes it's useful. And we have also the data for the second program to design the systems. So the minimum information is here, that you've got the symbol of each room, you've got the internal temperature, and you've got the heat load. Heat load, possible extraordinary heat gains, and description. This is the minimum information, and that's enough to design the system in the table method. In case of using the graphical method, you import not only this table but also the model, but I will speak about that in the second part of the presentation. That was from my part about the first program, about Audytor HL or OZC. This is the same. I see that so far you haven't asked any questions, but still you can ask questions about any software, about HL or about SET, that we'll speak after the break. And now I would suggest 15-minute breaks. So in Warsaw it will be 11. So you have to recalculate that into your time zone. You can relax for a second. You can drink tea, coffee. I cannot invite you to drink coffee exactly. Yes, I do invite you to drink tea or coffee, but unfortunately today we have the self-service, so you have to prepare it on your own. But I have also my cup of coffee, so I can drink it with you. Yes, there's a question. Is it possible to import a DWG Autocad file? Yes, it's possible, but because the question has just arrived and I already promised the break, so I will answer this question after the break. So now I say that yes, it's possible, and I will discuss it a little bit more in detail after the break. So see you in 15 minutes. All right, so we are going to start in a moment the second part of our presentation. In the second part, I will speak about Audytor SET, so the program to design the heating, cooling, and internal water supply systems. So the newest version of Audytor SET, it's 7.1. Again, available as Audytor brand name or in branded version. And Audytor SET, this is one application that integrates three modules that used to be separate programs. Separate program Audytor CH for central heating system design. Now we have separate module CC for central cooling system designs, and then what was separate program Audytor H2O for internal water supply systems. And now we have all these modules in one application. Why is that? Because it's much better for you and for us. It's much better for user because you can design different systems, you can check easier collisions, you can keep just one program, and also very important for us, it's easier to maintain the code and it's easier to develop. And if it's easier for us to develop, again, it's better for you because you can obtain the newest functions at the same time for all the modules. So it's not like that anymore as it used to be, that depending on the period, in some period the CH program was more advanced, in some H2O. So now the programs, the modules are not competing between each other. doesn't matter whether you design central heating or cooling system or water supply systems, you obtain the newest functions at the same time. So I think it's pretty important. And again, like I spoke about the main methods of designing in Audytor HL, again, I would like to speak also about two main methods of designing in Audytor SET. In Audytor CH, these methods were available even before integration, so from version 4.0. First, more traditional method, designing on diagram. In this method, you have to draw the diagram of the system, and that's all what you have to draw. It is pretty easy, especially in case of the vertical systems, but there are some disadvantages. First, that this drawing doesn't represent in scale the horizontal lengths. The horizontal lengths of the lines representing pipes are random, doesn't represent the reality. So the consequence of that is that you have to enter manually all the lengths of all horizontal pipes. That can take you some time, depending on the size of the system. And the second consequence is that you obtain only the diagram that can present results, but not the plan views from this diagram. And from version 4.0, there is the second method, newer, more modern, designing on plan views. Here you design on the flat plan views, and a little bit in a similar way like in Audytor HL, the program creates the third dimension. So we obtain the full 3D model of the building, and the program can take the lengths of all the pipes, both vertical and horizontal. So you don't have to enter any lengths of pipes manually. So you save a lot of time, and also you obtain the plan views later on that are useful for the constructor. But generally, you have two methods to choose from. Maybe in some cases, especially in vertical systems, maybe in case of renovations, you would choose the first method. In most cases, especially in case of new buildings, I recommend the second one. As I already mentioned, we draw it on the flat plan view, which is pretty easy and fast, and the program creates the three-dimensional model. Now creates also axonometrical projection that I will show in a second, but now you can see this visualization that is a little bit similar of the visualization of the building in Audytor HL. And we obtain a lot of information, the feedback from the market. That kind of presentation, visualization is very useful when designers speak to non-technical people. For us, maybe it's a little bit hard to understand why some people won't understand the technical drawings, but this is reality that kind of drawings can be easier to understand for some people. So it's kind of additional advantage of this visualization. You can see the whole building, or like now, one story. If you would like to see some details, we can choose viewing one story only. As you see, you can see the system. We can see also the model of the building, the walls, but the walls are flat. They are flat because they shouldn't hide the system. So this is purposely done like that. And you can see and you can verify whether the system is correct. And in the newest versions, version 7.1, we obtain also the axonometrical drawing. There are different solutions. We suggest this format that the stories are separated, so the elements are not overlapping, but it's not obligatory. There are quite a few options that you can customize the style of this drawing. And this is really the complete model. You can see all the elements. And this drawing is prepared automatically by the program. Our role is only to select or to change the options if necessary, and to add the labels of the elements if necessary. And here you can see the automatically created axonometry on one story. And there is this function related to axonometry that may seem pretty small, but in fact it's very powerful and really can save a lot of time. This is the synchronization of the labels on different stories. If we activate this option, when we change something, for example, like here we change the position of the label on one story, it will change, if such a label exists on other stories, it will change in the same way the position of all the other stories. That makes possible organizing the labels in big buildings in a very short time. All right, so that was the presentation. Now let's go to the program Audytor SET. So again, integration of 3 modules. Let's go to again to general global data. So as you see, the idea is the same, that you've got the global data and then global results. And here you've got the scope of calculations. In this example, we have 3 systems, so everything is checked in. Central heating systems, designing central cooling systems, and designing the water supply systems. Maybe now I will ask a question myself, because you might think, okay, if the program integrates 3 modules, so we have in fact 3 programs in one program, in one application. So isn't this program 3 times as bigger? Doesn't it consume too much internal memory? Will my computer work with it? Don't worry, because the answer is that the internal structure of the program is that majority of the code is the same for all these programs or these modules nowadays. So in fact, after integration, the size of the program has grown by about 5%. So it's 5% bigger, not 3 times. So don't worry. The amount of memory that the program uses during operation, you can check easily. But then you will see that it's really, really moderate. It's not that you have to possess very, very powerful computer to do the calculations for a very, very small house. It's the opposite. However, in the real design, I will recommend you to select only these options that you will need. So if you don't need to design a specific system, don't switch it on, because then you will not have to enter some data. In this example, we have all the systems. And now let me show you this example. Let's go to the basement. Now I have all the systems active, so I can look for the collisions. But when I am designing, I think it's easier to see one system only. You will see also that some labels are overlapping. This is why, because we believe that if we prepare the technical documentations, we rather prepare it system by system rather than all the systems at one joint. If you prefer all the systems at one joints, of course, you would have to rearrange these labels. How to see just one system? As you see, there are these modes, these working modes here, these appropriate tabs, and also the checkbox over. So this is the tab for the heating system. If I select this tab, this will be the active system. I will be able to edit only this system. The other systems will be frozen, but they are still visible. I can, using this checkbox is over, I can switch them completely off. So now I can see only the heating systems. If I choose now, I will see only the cooling system. And now the program will show the water supply system. So the other systems may be not visible, or the other option is to make it visible but in not so intensive color. So using this left scroll bar, we can scroll to the right, and then you will still see the other systems, but they will be less visible. So depending what you prefer. All right, the most effective way, especially in case of designing the heating systems, is to import the model of the building from Audytor HL. How to do it? You have to go to the File menu, and then we have this option, Import Building-Based Drawings from HLC, and then we have to find the OZR. The R is for results. So we import the file with the results from the Audytor HL, and if we have used the graphical method in Audytor HL, this option will import not only the heat load results, we can see the heat load results here, data rooms. So as you see, this is the table with the results of the heat load calculations. You've got the heat load in this column, Phi HL, but also if we go to drawings, we obtain the model of the building. We obtained it as the plan view. If I select this third mode, so then the building will be active. So in fact, we don't obtain the full 3D model because we don't need it. We need just the plan views, the architectural plan views. So basically walls, windows, and doors. And what's important, this is the logical model rather than graphical, because if I come with the cursor to the wall, then at the very bottom of the window in the program, in the status bar, I can see that this is external wall. I can see the symbol and everything. The same in case of window. I can see that this is a window. And thanks to that, a lot of functions that makes it easier to design, for example, automatical inserting of radiators under windows can work. So really designing the systems using this model of the building is very fast and effective. Of course, you can say that not always you possess the model in HL. Maybe if you prefer to design only cooling or only water supply systems, then you won't need to calculate the heat load. So what in this case? In this case, you can draw the model in SET program in a pretty similar way. Again, you can import the Autocad file. Let me, if I have something, just an example. So I can import it, and over it I can draw. So this is the base drawing, and I can, with some preciseness, I can draw walls. The other thing is that you can see that maybe I don't need to draw the walls to have this logical walls. Maybe it's enough what I can see from the AutoCAD file. Yes, it's also possible. Probably it's the fastest way. There is just one thing that is obligatory. This is to create the room zones, because the program needs this information. Each element must belong to one of the rooms. So the minimum program is just to create room zones. So in this case, you select more or less in the axis of the walls, and then you create the room zones, and then you have to enter the symbol and the internal temperature. So that's a kind of minimum solution if you don't have the model from HL program. Okay, so maybe let me clear it up. And like in Audytor HL, we had these two models, geometrical and calculation model. We have also two sets of drawings in Audytor SET. This is kind of main principle. These drawings that you have so far, these were drawings with data. For example, if you have a look at the radiator, we have information that it should be CV asterisk asterisk, so the program can select not only the length of radiators, but also the number of plates. But you can see here the selected radiator. To see that, first we have to run the calculations. Because we have three systems, so we have to decide whether we would like to calculate all the systems or only just one of them. I have started calculation of the heating system, but we have to remember that in this case we won't have the results of other systems. But in case of big buildings, maybe sometimes just to save time, you would prefer to calculate at a specific time only one system. Again, there is a diagnosis. We have some overpressure. Generally, it's like that the program has got some criteria and checks possible problems. And if we would like to locate the problem, we double click and we see that this is the underflow radiator. That's, yeah, in fact, in case of underflow radiator, that happens. We've got this overpressure and very often there's not much we can do. The general principle is that this is just to point your attention at a specific situation. I think that's very useful, especially in case of big buildings, but you have to decide as experts whether it's worth and economical to do something, to take some action or no. So now, after calculation, we can switch to the results. Maybe let's keep just heating system for the time being. And now I can choose result drawings, or there is this button here. No, it's under results, in fact. Or there is very useful key shortcut. Just press Ctrl Tab. And after a while, now the program must load the file with the results. For the first time, you have to wait a second. Yes, and now you will see. And now this is the drawing with the results. So you can see that now the program has selected not asterisk asterisk, but 1 radiator. It means that this is one panel with one convector, 1 meter 60 centimeters long, and the preset on the built-in valve is 2. So these are the results of calculations. When I press Ctrl Tab again, so I moved back to the drawings with the data. And now, as you see, very fast I can switch between drawings with data and result. Just keep in mind that you can edit only the drawings with data. The drawings with the results is created automatically by the program during the calculation, so it always reflects the time of the last calculations. So that's very important that we can see the results of calculations in the form of the drawings, the plan view. If we have created, we can see also the axonometry. Maybe let me speak shortly about the options of axonometry, but let's move back to the drawings with data, because these are the drawings that I can edit. So, as we said, we recommended this possibility that the specific stories are separated, but this is not obligatory. I can switch this option off, and now it looks like that. So with architecture, it's a little bit, I think, too confusing, but of course you can switch off the architecture using this third checkbox here. So now I think it looks better. You can still see the room zone, so I can switch it off here. And then now we see only the underfloor radiators. Okay, it's good. So if you prefer, it's also possible like that, but probably without architecture, because with architecture, I think in most cases, this is the small building. And in a big building, it will be even more difficult to see anything. So with architecture, but we believe that this drawing is pretty useful, because you can see everything, and also in the good context of the building, that I believe it's also pretty important. You can change the angles if necessary, and these green squares always return us to the default values. Here I can decide whether I would have this frame around each story, and then also drawing the room zones and underfloor radiators. And also, if we separate the stories, so we sort of cut the pipes, but we have this connection between these cut risers, and we can decide whether to draw them or not. So as you see, we've got quite a few options, and the most commonly used options are here available very fast. But if you press this gear, you will have the window, and now you have all possible options, including also the margin. So as you see, this drawing is done automatically. You just have to press the button update here to create it or update it. But you can influence the way that's prepared in quite an extensive way. Okay, but a part of drawings, which I think are very important, because as we keep saying, there's drawings, this is our language, the language of engineers. We obtain also the results in the form of tables. So again, we've got the global or general results, like in case of Audytor HL. But we have also some more details. For example, we've got rooms, and then here you can check the heat balance of each room, heat load, and the heat that you supply by the system, and the possible deficits. And also you may have the radiators in the rooms. And then you've got tables again with heat sources, pipes, accessories, etc., etc. So I won't show all of them. They just present the information in details about all this equipment. I would like to show you especially this one, last one, the circuits, because it makes possible to analyze the circuits and possible problems. Just imagine that our resistance of the system is very high, which especially the projects that I get to verification, that's a relatively common problem. For example, if I go to the results with pumps, here we don't have any information because we didn't place it. Should be placed, but we can check that also here in the global results. We can check here the required disposal pressure in the heat source, and then as you see it's 13,000 pascals, so it's very moderate, so it's okay. But it happens that this value is very high, like over 40-60,000 kilopascals, and sometimes even much more. So it means that the resistance of the system is very high. And then how to locate the problem? First, it's worth to look for the critical circuit. So which circuit creates that kind of problem? So we go back to the drawings of the results, and then you have this option here. In the right bottom corner, there is this second from the bottom showing the branches in case of a water supply system, and heat circuits in case of heating or circulation circuits. And then we can see which is the critical loop, and we see that this is the loop, the circuits through this radiator. So now I can right click it and have here this is the new option in the version 7.1, the command show the circuits through this receiver. And then I can see the program opens underneath the table of the circuits, and it opens it at the position of this specific radiator. On the circuits through these radiators, we can switch off possibly some columns that are not so important, and then observing the column delta P, so the pressure drop on each element, we can go one by one and look for the guilty one, where we have some extraordinary high resistance. That really helps solving the problems, if happens the problems like that. I think it's relatively common problems, especially in case of the people who are beginning work, sometimes not only. And speaking about the results, last not least, we obtain also the material lists. So all these systems that, all the equipment and materials that were used to model the systems can be now set on the list. So let's start with pipes, for example. And we have here these tables, two tables in fact. There is, first one is always a more detailed table. Here you can see the pipes that were used in this system, divided for the diameter. So it's a kind of shopping list, you know what pipes you need to buy. And the second one is in a little bit more synthetic way, so the same information. And you can see the same for all types of the materials, for example, radiators. Again, more detailed list, so different types of radiators, and then divided for sizes, and a little bit more synthetic ones. Depending which one you prefer, you can use it. So to buy the equipment, to prepare the offers, that can be pretty useful. All right, so that's everything that I planned to speak about. Now we can start the question session, but I cannot see any new questions in the meantime. So if you have any questions, please now write them using the question panel. I would recommend you to detach this panel. Beside the X symbol, you've got a symbol it's a kind of square with the arrow pointing to the left top corner, and clicking it, you can detach it. So you make this panel bigger, and please ask a question. Of course, you can always send questions to us using the email. I would like to encourage you to download either the trial version or to order the sponsored version by Khan or Danfoss company and try to work that. Also, you can follow the video manuals available on YouTube and also available from the help system of the program. And in these tutorials, you've got the explanation just step by step what to do to design it. First in HL to model the building and then to design a system. But I hope that after today's presentation, you've got already the general idea about how these programs work and what are the main methods of operating them.